Section 10.2, Vectors in a Plane. A vector is what is called a directed line segment that has two things. The first of which is direction, and the second of which is magnitude. Okay?
Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
Now what vectors look like are simply rays or arrows. We can have vectors of varying length, and we usually write vectors with a little arrow above them. If I call this point A and this point B, I can call this vector AB. This is what's called the initial point, and this is called the terminal point. The direction does matter because, for instance, if I have another vector like this would be different. This would not be vector AB. This would be, vector CD. They would be opposite, so I could actually say vector AB equals to negative of vector CD. We have something called equivalent vectors. We say that two vectors are equal if and only if they go in the same direction and they have the same magnitude. The magnitude of AB, sometimes you'll see it written with 2 bars, sometimes you'll see it written with only 1, but that represents magnitude. There is something called component form of a vector, and there's also something called the linear combination form of a vector. With component form of a vector, we use these pointy brackets, v1, v2. If you have a vector starting from the origin, so if its initial point is at the origin, and the terminal point is at some coordinate v1, v2, we would call this vector v, and we would say it equals to v1, v2. And this vector is also in standard position. If I were to say, find me the magnitude of vector v, that would be equal to the square root of v1 squared plus v2 squared. Okay, so let's just do some really simple little examples. Let's say I have vector AB, where the initial point A is at 1, 1. The terminal point B is at negative 1, 2. I want us to write the vector in component form, and then I also want to find its magnitude. We'll make a little sketch. So if A is at 1, 1 and B is at negative 1, 2. When you draw your vector, it's going to look like this. It's going to point from the initial all the way to the terminal, but I want to write this vector in component form. So what you need to do is think about what this vector would look like, but in standard position. So if I were to kind of take that vector and slide it over so that it's in standard position, where would it be pointing? Well, it's pretty easy to see with how I've sketched it. It's going to end up over here at negative 2, 1. So we would say that vector AB in component form is negative 2, 1. Calculate terminal minus initial. So that would be negative 1 minus 1 and 2 minus 1. What's the magnitude? It's going to be the square root of negative 2 squared plus 1 squared, or the square root of 5. A unit vector is simply any vector that has a magnitude of 1. What was our magnitude of the vector that we did in example 1? It was square root of 5. Well, if you take your vector, which is negative 2, 1, and divide it by radical 5, I would now get negative 2 over radical 5 and 1 over radical 5. I have now forced my vector into the length of 1. A little definition for it will be vector u will be any vector divided by its magnitude. Now you also need to be able to perform simple vector operations, such as adding vectors together, subtracting vectors, and also multiplying by a scalar. So let's say we have vector u, which is 1, 2, and vector v, which is negative 2, 3. I want us to calculate u plus u, and also express it graphically, and calculate u plus v. So now before I begin, I'm going to sketch vector u and vector v over here on the right hand side. I want to add another vector u, so I'm just going to connect them. Take a look at how long that vector is. That vector is now 2u. The terminal point is now 2, 4. So when you are adding vectors, you can simply add their components. Now what about adding vector u plus vector v? If I want to add two vectors together, we need to add them in a special way. The way we add them is by doing a process called connecting tip to tail. This vector that I've just drawn in will represent our resultant vector, and that's going to be vector u plus v. So let's look at the calculation. Vector u is 1, 2. Vector v is negative 2, 3. So if we add their components, we get negative 1, 5. Let's take a look at our vector. Is that at negative 1, 5? Does it go over 1 to the left and up 5? Yes, it does. We are going to talk about tangent and normal vectors. Find all 4 unit vectors that are tangent and normal to the parametric curve x equals to ln of t minus 1 and y equals to t minus 1 at the point t equals to 3. This is really x equals to ln of y, or y equals e to the x power. Now I want to know where the unit vectors are, tangent and normal, at the time t equals to 3. Now when t equals to 3, we have ln of 2 as our x value, and our y value is going to be 2. So now this isn't going to be perfect, but I'm going to approximate it. So this is 1 and 2. So that means we're at this point right here, which happens to be ln of 2 comma 2. But I want to know what the unit vectors are that are tangent to this point. Now from exactly where we are right now, you should be able to envision the tangent line that goes through there. Well, how is it possible that there are 4 total unit vectors? Well, there are 2 that are tangent and 2 that are normal. And the 2 tangent ones, there's one that goes in this direction, there's one that goes in the other direction. Because the directions matter for these vectors, we don't know which way, so there's one that's going to be, for instance, a positive vector v, and the other one will be a negative vector v. And then how is it there are 2 normal vectors? Well, one goes in one direction, one goes in the opposite direction. So I want to find those. Now in order to find those, I need to know what the slope is at that point. So I need us to find dy dx at t equals to 3. We need to find dy dt and divide that by dx dt and evaluate at t equals 3. What's dy dt? It's 1. Now what's the derivative of the x value with respect to t? That's going to be 1 over t minus 1 times 1 for the chain rule. So we can simplify this and get t minus 1, and we have to evaluate at 3. So we get this equals to 2. So what does this mean? The slope at the point ln of 2, 2 is equal to 2. So now I need to be able to write the tangent vector that goes with this. We know that the tangent vector has slope equals to 2. But now we have to write the vector for this. Let's just think about this now as a whole new set of axes. I'm going to draw a line that has a slope of 2. So let's say this is y equals to 2x. Pick any point on that line. So the easiest one is going to be the point 1, 2. I can write this out as a vector 1, 2. Then we need to turn it into a unit vector by dividing by its magnitude. So I'm going to have 1, 2 divided by radical 5, and I'm going to have vector 1 over radical 5, 2 over radical 5. What we have here are 2 different unit vectors, one leading into quadrant 1 and one leading into quadrant 3. These are the tangent unit vectors. What do you know about the slope of a perpendicular line compared to this one? Well, the slopes have to be negative reciprocals. So that means it would be going in the other direction this way. The slope should be negative 1/2. So we have the point that we can use on here, negative 2, 1 instead. Divide that by its magnitude, and we'll get negative 2 over radical 5, and then 1 over radical 5. The way that we can describe 2 separate vectors with this would be to make it minus plus and plus minus so that they switch. And this one right here that we just wrote out would be the 2 normal unit vectors.